So that's kind of intro level. Let's go ahead and look at one more thing. Since I know this, when you're able to figure out that two triangles are congruent, of course, we're going to bring in some algebra and we can solve for missing values. So first things first, based on the numbers and the markings, do I have congruent triangles? Yeah. So remember, these markings, in case we haven't seen them or remembered what they are, the markings tell you which sides are congruent to each other. So here this tells me that the two red sides are congruent, the two green sides are congruent, and then the two orange sides are congruent. So we already know that all of the sides are congruent, and then the two angles match up. So the last thing I need to figure out is how much is the value of x. So this comes back to what I was saying at the very beginning, the triangle sum theorem. What does the triangle sum theorem tell me? Yeah, it tells me that the three sides of a triangle, so A, B, and C, the three angles add up to 180 degrees. So could I figure out the value of this missing angle L and angle P? Yeah. So let's look at angle L. We know that angle L is going to be 180 minus 45 plus 55. So what's the measure of angle L? Good, 100. Okay, because 45 plus 55, what does that give me? So, okay,
1,000,000, 100,000, million, 100,000, million, 100,000, billion.
I was confused by all the numbers because half the people were saying 80 and then half the people were saying 100, but which one's which? Okay, so 45 plus 55 gives me 100. So 180 minus 100 is 80. 80 degrees. So I know that this is 80 degrees. So I know that angle P also has to be 80 degrees. And now I can use this knowledge to set up my equation and solve for x. So what should I write down for my equation? Right, it is 80, but we're trying to find the value of the variable. So I know that angle P is 80, but I don't know the value of x yet. So what equation can I set up? Yeah, 5x plus 30 equals 80, and I see Jalen already got the answer, so we're just going to subtract 30 on both sides. What's 80 minus 30? Good, 50. Divide that by 5, and I get x equals 10. Good job. So that's it. So again, using this theorem, using everything we know about triangles, we can figure out this information. So I want you guys to try these on your own, 7 and 8. You're going to find the value of the variable, not just the angle, but the actual variables. So I'm going to give you guys 2 minutes. No, not 2. I'll give you a little more than 2. I'll give you 5 minutes. 5 minutes to do number 7 and number 8. Perla, I just saw your question. Let me go back really quick. P is not 10. P is 80 degrees. It's just that x is 10. Okay. Thank you, Jalen, for also saying that in the chat. All right, so 7 and 8, time has already begun, so go ahead and get started. Yes, you can give me the answers in the chat. About a minute and a half left. Many of you sent me your answers for X. Does anyone else have an answer for Y? I've only had one so far. Okay, that's time. Okay. All right, so for number 7, when we're solving for the value of X, first thing to do is figure out the value of the angle, the whole angle itself. So angle B and angle E, how much do they have to be? How much do angle B and angle E have to be? I could barely hear it. Okay, 43, good. So I know that this has to be 43 degrees and this has to be 43 degrees because I'm subtracting from 180. And then I can set up my equation. What's my equation? Okay, I know that X plus 17 has to equal 43. So what's my value of X? Good, 26. So that's number 7. Now for number 8, I'm not looking at the angles, I'm looking at the sides. And I know, so I have to do a little bit of matching because they're not in the right orientation. So I know that this 22 matches with this 22. This 15 matches with this 15. So this was, you have to be very careful that the side we don't know about has to match up with the 32. So if you set up your equation using any of the other numbers, you would have gotten the wrong answer. Your equation should have been 4y plus 12 equals 32. Okay.
That means y is 5.
Yeah, that means y is 5. There you go. Subtracting 12, you get 20. Dividing by 4, you get 5. So y equals 5.
You spelled my name right.
All right, Perla, nice. Okay, and then one last little thing is just to remember that these markings on the triangles also show you the corresponding angles. So I know that the 2 green angles are congruent, the 2 little purple angles are congruent, and then this one has 3 lines on it, and this one has 3 lines on it. So we know those are congruent. So the number of little arcs that they put on them matches. Okay. Questions on number 7 or number 8? This is pretty simple stuff so far. Let's do another one that's a little bit longer, but with the same idea. So I have 2 variables. I have X and I have Y. I need to find both of them. So I want everyone to just spend 15 seconds looking at the diagram, noticing the similarities, noticing the differences. Start thinking about what types of equations you might be able to set up. Okay. So first things first, let's play a game of matching. So I'm going to match up my angles. So obviously I know that the 84 matches with the 84. Which angle does angle P match up to?
L.
L, good.
L.
What's one way that you can tell?
Rotate the triangle on the right.
Okay, so you can tell that if you,
based on Q and M.
Good, so you can sort of rotate it and see. The other thing I want you guys to just notice is that the L is in between side with the 2 tick marks and the side with the 3 tick marks. And that's also the case for P. It's in between the side with the 2 tick marks and the side with the 3 tick marks. So if it was a little hard to tell, you can always tell by looking at which 2 sides that angle is in between. So based on this information, what type of equation could I set up between angle L and angle P? I already see somebody sent it privately, and that person, maybe you can send it publicly instead. Good, Janelle's. So you can set them equal to one another because we know they're congruent. So this would be 3x plus 24 equals 7x minus 4. Okay, and we're going to go ahead and solve for x. So here we go. What can I do first to solve for x? Move to the left. Move which variable to the left? Yeah, good, minus 7x. Minus 7x minus 7x. 3 minus 7 gives me negative 4, good. So I have negative 4x plus 24 equals negative 4. Now what do I do to both sides? Good, minus 24. Minus 24 minus 24. What's negative 4 minus 24? Good, negative 28.
Divided by 4.
Good, and Daniel, what do you get?
X
Oops, that should be negative.
X, no, it's positive.
Yeah,
X equals X equals 9. No, 9. I'm dumb. X equals 7. I'm dumb. Sorry, I'm dumb.
All right, Daniel, you got it eventually. Good, x equals 7. All right, so I have x. Now I need to figure out y. But this is where it gets a little bit challenging. So I want you guys to think about it for a minute. Spend 30 seconds thinking about what strategy you might need to do in order to find the value of y, because this right here has a y in it. What would you possibly need to do? Okay. So Perla was saying, okay, what's the value of P? Right? Because right now we only know the value of X, but we don't know how much that whole angle measures. And if I need to figure out the measure of angle N, I can't do that until I know the value of the other angles.
Oh, what's up, baby?
Daniel, calm down. Okay. All right, so Perla says I need to plug the 7 back into the equation, and Janelle's just said that as well. So I'm going to go ahead and plug in a 7 into this equation, into this expression. So I have 7 times 7 minus 4. 7 times 7 gives me, good, 49, and then 49 minus 4 is 45. So I know that angle P is 45 degrees, which means angle L is also 45 degrees. And what does that mean about angle N and angle R?
Read. They're the same.
They're the same, and can I figure out how much they measure?
Yes.
Yeah, how do I do that? It's Samaj says yes, you guys at. Good, 180. So I have to add up 45 plus 84. That gives me 129. And I do 180 minus 129. What do you get? 51. Good, 51. So now I know the measure of all the angles, and how can I use that now to solve for y?
Now,
Yeah, Jalen says plug in.
Subtract 14.
Okay, so let me erase
Subtract
here.
4.
Thank you, Daniel. Very excited today, Daniel. So I know that 2x plus y has to equal 51 degrees. I already know the value of x. Good. Tyrone is saying x is 7. So I can plug in x. 2 times 7 is 14. And just like Daniel was saying, we need to subtract 14. And what's 51 minus 14? 51 minus 14. 37. Good. So y equals 37. So what did I get for x? X was 7. And y was 37. And now I know the value of all of those angles for both triangles. 30. Okay, any questions on this whole problem? This was kind of like you really had to put in a little bit more work and really strategize to get your answer. So does anyone have any questions? All right. All right, one more. Can I have a volunteer read this one? It's a little bit long, so who feels courageous today? Tyrone, do you want to unmute yourself and see if it works without the echo? Perla, try it. See if it echoes, and if not, you guys know how to fix that.
Okay. Oh God.
Oh God, what was that?
Mr. I already muted him, but you have to like turn off the.
Miss, can you hear me? Okay,
Yes.
yeah, you can.
Yeah.
Okay. Kelly was asked to determine whether triangle KLN is congruent to triangle MNL. She noted that line KL is congruent to line MN and KN is congruent to ML, and that the 3 pairs of corresponding angles are congruent. She said that this is only 5 pairs of congruent corresponding parts, so it is not possible to conclude that triangle KLN is congruent to triangle MNL. Do you agree? Explain.
Okay. So this goes back to the definition of CPCTC. Remember that what I said is every single pair of angles has to correspond. Every single pair of sides has to correspond. So let's go ahead and check what we have and see if it's enough information. All right, so like she says, oh my bad, I got disconnected, hold on. There we go. All right, so like she says, she noted that KL, so line segment KL is congruent to line segment MN. So that's the 72 and the 72, those are congruent. And then she noted that KN is congruent to ML. So that's my 44 and the other 44. And then all of the corresponding angles are congruent. So I'm just color coding everything. So N is congruent to which other one? Good, L. K is congruent to which other one? Good, M. And then, what color haven't I used yet? Purple. Okay, this one over here is congruent to this one over there. Okay, so I have how many pairs of corresponding angles? How many pairs of corresponding angles have I found? How many match? Yeah. Okay, Tyrone says 3. Do we agree? Well, obviously Tyrone agrees with himself, but everyone else, do you agree with him? How many, okay, are you confused by my question? Because it's an easy question. How many angles match up to each other? How many different angles are there that correspond to one another? Okay, let me break this down. Angle K is congruent to M. That's one pair. Then I have angle NLK. What's that congruent to? M and L, good. And then I have angle LNK, and that's congruent to? Good. Wait, LMN, say that one more time. Make sure you have it in order, Tyrone. You want L in the middle. And LM, there you go. So we have 3 pairs of corresponding angles. Does that make a little more sense now? Yeah, Tyrone was right from the start. All right, so we have 3 pairs of corresponding angles. What about corresponding sides? Somebody give me 1 pair of corresponding sides. N and L. Give me a full line segment. So like Perla says, KN is congruent to LM. Somebody give me another pair of corresponding sides. Good. Jalen had it. KL is congruent to NM. So I have 2 pairs of corresponding sides so far. But remember, I need 3 pairs of angles and 3 pairs of sides in order to call these 2 congruent. So what do you guys think? Is there a third set that I can make? Is there a third side that I can say is congruent? Tyrone says yes. The purple ones. MN and KL. Yeah, we already did that one. Which pair of sides is missing? Okay, so Perla says LN and NL, and that is correct. So let me erase everything else I've got here so we don't confuse everything. Okay. So far, I'm only talking about side lengths. I have this blue one, goes with this blue one. Wait, sorry, KL, no, blue is these. So I have this blue one, goes with this blue one. I have my oranges. I have KN and LM. And like Perla just said, we also can make a pair between N and L. N and L is congruent to LN. So what's that saying? It's basically showing you that both triangles share that same side. They share it together, and because they share it, it has to be congruent to itself. And so what this is called, and I want you guys to write this one down, is the reflexive property. The reflexive property is when you state that a side or an angle is congruent to itself. So I could add little tick marks now. I'll add 1 tick mark for my orange. I'll add 2 tick marks for my blues. And then for my green, I'll put 3 tick marks because that is congruent to itself because it's the same side. So it's the reflexive property. Any questions about the reflexive property? So are these 2 triangles congruent? I have 3 congruent angles, 3 congruent sides. So I can say, what's the magic word? What can I say? CPCTC. CPCTC. Okay. All right. One last definition for today. Can I have a volunteer read the ASA triangle congruence theorem?
Me. ASA triangle congruence theorem. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent.
Thank you. All right, so let me break this down. So ASA stands for angle, side, angle. Yeah. Angle, side, angle. So what this means is that if you have a triangle, remember what I just said, CPCTC is when all 3 sides and all 3 angles match. ASA tells me there's a theorem, and remember, theorems are like rules. It tells me that if the 2 angles and the included side of one triangle is congruent to 2 angles and the included side of another triangle, then both triangles are congruent. So let me show you what that looks like on these triangles. So notice, I have 45, right? Does that match with anything so far that I see? Angle F, that's 61. So that doesn't match. Angle D, okay, if you add up and then subtract from 180, 74 plus 61, what does that give me? Good. Good, that gives me 135, and then when you subtract that from 180, you get 45 degrees. So yeah, so angle D is 45 degrees. So I know those match. And then I have angle C, so this 61 matches with F. So I have 2 angles, and I have the included side. So what it means by included is that it has to be in between those 2 angles. So notice how I have the green angle and then 2.3 and then the blue angle. On the other one, I also have the green angle, the 2.3, and the blue angle. If you have that pattern where you have 2 angles that are matching and the side in between them is matching, you can say that the 2 angles are congruent. So what I would say here is triangle ABC is congruent to triangle, what do they match with? Can anyone tell me? ABC is congruent to, what's the correct order for my other 3 sides? Good, D, E, F. Because of the ASA triangle congruence theorem. All right, so my 3 guys who are at school are moving to a different classroom, so I'm just going to pause here for a moment and wait for them to get to the other classroom. Okay. All right, so I want to determine whether these 2 triangles are congruent, and I need to use ASA. So remember, we're trying to see, I need 2 angles that match and the side that's in between those 2 angles. So let's look at number 7. In number 7, I don't have any numbers, but I do have markings. So what are the markings? What's one relationship that I know is congruent based on the markings? Number 7. Number 5. Sorry. Number 5. So what's one relationship that I know? Okay, so Tyrone says angle B and angle C are congruent. I know this because of the markings. What's another relationship I can set up? Okay, so I see 2 of them. So Perla is saying that AD is congruent to DA. Yes. What's that property called again, Perla? The reflective thingy. The reflexive property. Because of the reflexive property, I know that these 2, or those 2, they share a side, so that side has to be equal.
They are same.
Okay, I also know, as Tyrone said, that BD is congruent to CD. Okay, so remember, I need ASA. I need angle, a side, and an angle. Right now, I have an angle and I have a side. So I need one more angle. Tyrone says on D, there is a right angle. So D has to be 90 degrees. Yeah. So angle D is 90, which means on the other side of that 90-degree angle, there also has to be another 90-degree angle. So now I have an angle. So I'm going to point all of the 3 angles out. So I have, this is my angle, this is my side, and this is my angle. I have ASA on one triangle. Do I have ASA on the other triangle?
Yes.
Yeah, I've got the same angle here, the side in between, and the third angle. So you have to match ASA on one triangle to ASA on the other triangle. Did our reflexive property end up, did we need the reflexive property in this case? Yeah, we can do it without numbers. Right, we did not need the reflexive property in the end because we have everything we need without it. So here I can say that triangle ABC, or triangle, let's see, ABD is congruent to triangle, how do I match?
Can you repeat
ABD is congruent to
ADC?
A, careful, what does B match up with?
Oh, ACD.
ACD. So ABD is congruent to ACD by the ASA theorem. So now I want you guys to take a look at number 6. Can you have, is there ASA
No,
in number 6?
no,
Okay, why not?
because there isn't an angle. Like, wait. I don't think there's a side because there's not the little mark.
Well, we don't have markings in number 6, we have numbers. So we can do it using numbers. Side R is not 67. Okay, so what did you get for side R, Perla? Side R is equal to 70. If you do the math, you get 70 degrees. So here we have angle, we have side, we have angle, but on the other triangle, what happens? I have angle, I have side, those match up so far, but the third one does not match. So I do not have ASA. So that means that triangle PQR is not congruent to triangle, oops, to triangle
STU.
STU. Good job. So how did you get 70, Perla? There you go. So she added up the two existing angles. So we had 38 and 72, right? So 38 plus 72, what does that give you? That gave you 110. And then 180 minus 110, that's how she got 70 degrees. Because remember, they have to add up to what?
180.
180.
180.
All right. What questions do you guys have for me?
None.
None?
Nope. Nope. Nobody.
No
Nope.
questions? No? Okay,
Ms.
let's do it.
Lopez,
Yes.
are you gonna give us any like more assignments, or are you gonna put more grades in?
Yeah, well, you guys are going to have a homework assignment this week and a quiz at the end of the week.
On
Okay,
Thursday?
it's because my grade dropped to a B and I had an A, and I'm kind of mad about it. But
You got to bring it up. Jalen, you have a question? What's up? Okay, Jalen, moving on. Yay, now we get to do proofs. This is exciting. This is the best part of the day. Okay, so go ahead and take a look at this proof. So I want to prove that these two triangles are congruent to each other. And I have to use my theorems in order to prove it. All right, so start thinking about all those theorems, start thinking about all those definitions we know, because we do not have a bank of answers here. So we have to just come up with it based on what we know. All right, so Tyrone, you can do number one. Good. What's number one going to be?
Given.
Given. Good. Remember, we always have to take a look at what we are given. And right here is our given statement. So remember, the first thing on the proof will always be given. And Tyrone, what do you think about number two?
I don't know.
Would anyone else maybe try to take a crack at number two?
It's
Miss,
given.
I
Yeah.
have an idea. Oh,
Daniel's completely correct. It's also given.
Oh,
In this case,
because
they
it says
actually gave us two different statements. They said angle A is congruent to angle C. So I'm going to go ahead and mark that.
Number 3 is given.
And then that E is the midpoint of AC. So if E is the midpoint of AC, what do
Then
we
3
know?
is given.
What do we know?
That they're equal.
It's congruent.
That they're congruent. Be more specific. What is congruent to what?
AE is
AE
congruent
is
to CE.
equal C.
Good job. Okay, which is what they tell us in step 3. Notice. AE is congruent to CE. And what definition or theorem or postulate did you guys think about? Because you guys told me the same thing. What is that called? What's the definition or theorem or postulate?
is it perpendicular bisector? No, right, never mind. Never.
Not quite, but you're very close.
It's not perpendicular either, so
It doesn't say anything about perpendicular, no.
what it is? Corresponding? Wait.
Okay, so here's one strategy to always use. Remember, we've used this in the past where if I'm trying to figure out number 3, I want to look back at number 2 and look for any keywords. What keywords did they give us in number 2?
Midpoint.
Midpoint. And remember, Daniel and Tyrone both answered this perfectly. They said that because E is the midpoint, that means that AE
Given.
is congruent to EC.
Mm.
What definition, you guys didn't come up with that out of nowhere. What definition tells us that?
Postulate?
What definition tells us that I can make AE congruent to CE? Nope. Let me draw this out for you guys. You don't have to write this, but here's what you guys just told me. So
Is it the perpendicular bisector theorem? No, never
does it
mind.
say anything about perpendicular?
No.
No. But here, let me give you the order of events that just happened. So it told us, it was given that E is the midpoint, right? They told us that. Then Tyrone and Daniel both told me that AE is congruent to CE. How did you guys know that?
Because of the line.
Which line?
I just took a look at the distance between A and C and assumed that it was an equal amount.
You assumed, but
Didn't you say like if I had a line, it's congruent to the other thing?
Okay.
Like a mark?
Yes, but I only drew the mark because you told me to.
I did?
Yes, because you told me that AE is congruent to CE.
Oh, wow.
Daniel and Tyrone both told me this.
Congruence theorem?
You don't have to quote me on this. Oh my god. Oh my.
Daniel and Tyrone both said AE is congruent to CE. How do you guys know that? You're right. How do you know
ASA?
it? You used ASA?
It wouldn't work.
Yes, it would. Never mind.
Janelle's gonna say it.
Janelle's, it's as obvious as you think it is. Exactly. It is because that's the definition of a midpoint. What did I tell you guys?
Why does it sound so simple?
Because it is. You guys are overthinking it.
I knew it, but I
remember
forgot
back in the day when we first started learning about proofs, I was like, okay, something you can say, if you walk outside, you can say the grass is green. Why can you say that?
Because it looks green?
Because it looks green, exactly. So it's simple. It's actually really easy. And the reason I was telling you to look up at number 2 is because number 2 says the word midpoint. Anytime that they give you a key word, the next step is probably going to be the definition of that keyword. Okay, so that's why it's really important, you guys, not to overthink proofs, because a lot of times they're going to be way easier than you think. Okay. In the next statement, so now that we know those two are congruent, they tell us that angle AEB, so AEB, this one, is congruent to angle CED, this one. How can I say that those two angles are congruent? Think about your definitions. What types of angles are those to each other? They're not corresponding. Think back to your definitions from last week. Good, Emily. Vertical angles. And I know that vertical angles are congruent because of which theorem? Remember, don't overthink it.
The like vertical angle theorem or line?
Yeah, literally. The vertical angle theorem. That's it. So you see what all I had to do was realize that those are vertical angles, and then, oh, boom, it's the vertical angle theorem. And now, finally, I can say that triangle AEB is congruent to triangle CED because what do I have here? What relationship have I figured out between these two triangles? So I have, okay, let me be more specific. I have an angle, I have a side, and I have an angle. And then over on the other side, I have the same angle over here, the same side in the middle, and the same angle over there. Oops, that's an A. So for that last thing, all you have to write is ASA congruence theorem. All right, so I'm not gonna lie, proofs are hard because the only hard thing about them is remembering the names of all those theorems. That's why I'm saying you gotta memorize them. But at the end of the day, they have to make logical sense. So most of the time it's gonna be kind of obvious. The hard part is trying to ignore that part of your brain that tells you it's gonna be hard, because it's not hard. Okay, like we just showed, it was actually kind of simple, but it's just a matter of like pushing that part of your brain aside and remembering that it's easier than you think it is. Let's try another one. This one gives you a little bit more information, so we'll see if we can figure this one out.
Given.
Okay, number one, we always know
Given.
is
Given.
given. Good.
Oh.
Okay. And notice, let me show you this again. They tell the keyword bisect. What do they do in the second step? Second reason?
Define it.
They define it. See what I mean? So there's always going to be that sort of pattern. Like if you bring up a new word, the next step is probably going to give you the definition of it. Okay. So they tell us that AB bisects CAD and CBD. So can anyone tell me what this does?
It puts it into.
It splits it in two and it makes it two,
Right angle.
not right angles, but two equal, yeah, like Perla said, equal angles. So if it's bisecting this whole big angle over here, then I can split that into two, and I know that this angle is congruent to this angle. I also know that it splits up this bigger angle over there. So I know that this angle is congruent to this angle. So I know this so far. Okay. Notice in step 2, they say CAB is congruent to DAB. So we've kind of given that the blue angles are congruent. So what do you guys think is going to be in step 3? Yeah, the purple. We did the blue. The next step is to show that angle CBA is congruent to, can anyone tell me? Finish that statement. Make sure that you match everything up. So CBA is congruent to, not quite. DBA, there you go. Because the B has to be in the middle. Okay, so that's the same, notice, this is both definition of a bisector, because all we did was use the first statement to help us figure that out. Now, reflexive property. Ooh, that should ring bells in your head. What is reflexive property? Oh, I see Perla. Perla already said it. Reflexive property is whenever you look at the same side as congruent to itself. So we know that this is the same. So I know AB is congruent to BA. Nice job. And then finally, I can say that CAB is congruent to DAB due to which congruence theorem? Good. Ooh, is it CPCTC or is it ASA? Have I proven that all of the sides are congruent and all of the angles are congruent? No, just I have one angle, I have a side, and I have an angle. So the only theorem that I can use here is ASA. So Tyrone was right, yes. Angle, side, angle. Do y'all think you could do one more? It's gonna be the last one. Yeah. Oh, don't leave. You guys can do it. I bet you can do it. Remember, when you get a brand new, fresh, oh my God, you guys complain too much. You really think it's that hard?
Why do we have to make the statements?
We got to do everything.
Miss, please don't do
Well,
this
we'll
to
do it
us.
together. We'll do it together.
Can't we just do the reasons?
No, you got to do everything. But
No.
guys, so easy. Okay. Pause here. Stop your complaints. What always comes first? What's always first? Given, right? It's always that's always going to be your first thing. Well, what is given in this proof? It's right there.
ADC and ABC are
Congruent.
reflected.
No, read. Okay, pause, Daniel. Right now, all we're doing is reading what they tell us to read.
Line segment AB is parallel to line segment CD. Angle ACB is congruent to angle CAD. There.
Exactly. That's all we're writing down. We're starting off with what we're given.
Given. Given.
Good.
Also given. Yay.
Okay.
I'm not
Now,
doing them.
we know that. Can anyone remind me what's always going to go last?
Proven.
Yeah,
Proven.
whatever you're trying to prove. So I'm trying to prove that triangle ABC is congruent to triangle CDA.
We can also prove that BC is equal to DA and AB is equal to CD.
Pause, because we don't know all that yet.
BD.
We only know things based on what we're given. So now let's go back and check the givens. I know that AB is parallel to CD, so I'm going to make markings. AB is parallel to CD. I also know that ACB, so ACB, this angle here, is congruent to CAD, right here. Okay, so let me see what I have here. So Perla says 5 is the reflexive property because AC is congruent to CA. Yeah, that's true.
That's what I said earlier. But I didn't say which number.
Right, we didn't say which number this is. This could actually go anywhere at this point because it doesn't depend on anything. But let's put it at number 5 because that kind of leaves us room for other things. So number 5, I'm saying AC is congruent to CA. And that is my reflexive property. So let's pause and see what we have so far. I have one angle. So I have an A. I have an S. But I'm missing one more angle. So I need to figure out if there's one more angle that I can call congruent. So if Angle A is one of the two. Which other angle do I need to figure out? So let me label these. Hold on. Should I try and figure out the purple angles? Or should I be trying to find the red, or no, the orange angles?
Orange.
If I'm trying to use ASA, I need two angles and the side in between.
We already have the side.
We already
need
have
to
the
figure
side.
out the purple ones.
Right.
Yeah,
you're right. We need to find the purple ones because the orange ones, that's not the right one that we're looking for. So we're trying to find purple. Is there a way that I can state that the two purples are congruent? Tyrone says yes. How can I state that? What theorem or print or definition or anything? What can I use to say that the two purple angles are congruent to each other? Not ASA, because ASA we use at the very end. We're trying to use ASA at the end. But we need to get there somehow. Right now, I'm assuming that the two purple angles are congruent, but I don't know that for sure yet. I need to use a definition to prove that.
This is confusing. This is why I don't like proofs.
It's okay.
My poor brain.
It's okay. Jalen's on the right track.
Alternate exterior.
Alternate
Interior.
interior. Okay, the two purple angles. So I have angle BAC.
I gotta go to office then.
And angle, we're almost done. So BAC and DCA are alternate interior angles. Those are alternate interior. And believe it or not, this is because of the definition of alternate interior angles. And since they are alternate interior, what can we say about them? Good, that they are congruent. So angle BAC is congruent to angle DCA. And what's that theorem called? Don't think too much about it. What do you guys think is that theorem is going to be called? It's the alternate interior angle theorem. So there's our proof. I know we kind of ran out of time at the end. We'll do many, many more of these to practice. Okay, but there's no homework today. There will be homework tomorrow that will be due on Thursday. So no homework tonight, but I'll give you homework tomorrow. You guys are all done.